last video, we went over supply and demand. We went over all of that. That's like a huge, dense section of the book, and where, the lot. Hope it was good. But in this video, we're actually gonna go over the actual example of the book. And let me try to pull out the example right here. So the example is, suppose that Greg Tobin, manager of a giant supermarket chain, has studied the supply and demand for watermelon. He has noticed that the demand increases as the price decreases. So we know that. The law of demand says as price goes up, quantity demanded goes down. We know that already. He has determined that the quantity in thousands demanded weekly, Q, and the price per watermelon, P, are related by the linear function. And I actually wrote down the linear function right here. So it's P equals D of Q, which equals 9 minus 0.75 Q. And I got this equation from the book. You can see as well. And I actually wrote down another alert. So this equation, P of Q, this equation, P, or D of Q, P equals 9 minus 0.75 Q. This looks pretty familiar. In fact, this actually looks like the slope-intercept form that we were working with. Let me see if I can pull out that one. Let me see if I can find where that one was. It's not this one. This one. Wow, where is it? Anyways, so it's the same. We can write it down. It's the same as y equals mx plus b. If you notice, they actually look really similar, and that's because they're the same. This equation is the same as y equals mx plus b. So you look at it. You have your slope, your rise over run, your rate of change, which is 0.75x, and then you have your constant, your y-intercept when x equals 0, which is your 9. And the only difference are the variables. Instead of y, you're using p for price, p for price. And instead of x, you're using q for quantity. So, sorry, it's a little distraction. So, it's the exact same equation as the y equals mx plus b. P equals 9 minus 0.75 q. The only difference is y is substituted for price and q is substituted for x. Q, quantity, is substituted for x, and then p, price, is substituted for y. But they're the exact same thing. Right? Hope that makes a little more sense. Okay, so the book states, it's asking you the question. Oh, and then here's actually a little note that I have myself. Y is the same as f of x. Just as p is the same as d of q. This actually means demand, the function of x. Right here. And this is basically the demanded quantity. Quantity, they mean the same thing. they mean the exact same thing. Y is equal to f of x, p is equals to d of q. So d of q is equals to 9 minus 0.75q, just like p is equal to 9 minus 0.75q. They're the same thing. It's I'm hammering this in because it's going to be useful later on. So the book basically wants you to do, for part A, the book wants you to do one thing, and it says right here, find the quantity demanded quantity, right there, DQ, at price of $5.25 per watermelon and at a price of $3.75 per watermelon. Okay, so first off, they gave us price, which is equals to $5.25, and then also a price of $3.75. And they want to know, find the quantity, so find Q, remember quantity, Q. Find the quantity demanded at the price of $5.25. So you have your P, your price, and you need Q. Well, remember that this equation is the exact same thing as y equals mx plus b. We actually wrote it down right here. Y equals mx plus b. They're the exact same equations. So what that means is, if someone told you, I have y, I need you to find x, how would you do that? Well, you basically plug in everything for all the values and then solve for x. That's the exact same thing you're doing in this problem. So you have a price. They gave you a price of $5.25. And you have to remember that there are certain keywords when you're reading a word problem. It basically boils down to reading word problems. That's the hardest part in mathematics, reading word problems. Find the quantity. That should automatically raise a red, alert. Find the quantity. They want us to find Q. So we don't know what Q is. But they gave us a price. Find the quantity at price of $5. So we don't know Q. We want to find it. But they gave us a price of $5.25. So what do? Well, we can plug in the $5.25 for price. We use the machine. We use the y equals mx plus b machine. We plug in a value so that it pumps out another value. So we know the 525, but we don't know the Q. So we plug in what we know. We plug in the 525. We do the math. It should come out to this. I'm pretty sure you know how to do the math. Just have, isolate the variable. So, subtract by 9 on both sides. You're going to get it negative 3.75 equals to negative 0.75 Q. You divide both sides by 0.75 and you get Q equals 5. So they want the quantity and you found the quantity. And that's pretty much how you solve this problem. You plug in, you basically write down my advice is I feel like it's less mathematical problems and it's more reading the word problems. It's a very odd thing to do. It's very hard to read word problems because you kind of have to dissect or take out information. For example, A find the quantity demanded at a price of 525. So find the quantity. That should automatically raise the red flag of we need to find Q. And they gave us a price at 525. So we write everything down in the corner, we write what we know, and we write down what we need to find out, question mark. And we go to our machine, which is our equation, and we plug in everything we know. There's always bound to be one variable that's going to be left alone, which is Q, that we're going to have to solve. But that's basically the gist of it. We grab the information, we grab what we need to find, the quantity. It says right here, find quantity, Q. And then we grab the information that's relevant. Price. Okay, we have a P. We have a price. So that's important. It's $5.25. So we have a price of $5.25. But we don't have a Q. We want to know a Q. So we use the machine. We use the linear function. We plug in our value for price. We do the math. Hopefully you have a calculator so you don't have to do all of this by hand. And the machine pumps out a value for Q. It pumps out a value for Q, which was 5 in this example. So at $5.25, the quantity demanded is 5,000. Well, why 5,000? Well, the book basically mentions the quantity is counted per 1,000. It's mentioned right here in the question. It's the quantity in thousands demanded weekly, Q, and the price in dollars per watermelon, P, so this is in the thousands. And we do the same thing for the second question. So the second question is basically asking, find the quantity demanded at the price of $3.75. And let me see if I actually did that example. I'm pretty sure I did do the example. Yeah, I did. It was at $3.75. So we do the same thing. We're given a price. So we're given a price of $3.75. But we're not given Q. We're told to find Q. So we plug in this information. Like I said, we use our machine to our advantage. We don't really want to do all this complicated stuff. So we use the machine to help us. We grab our information that we know and we plug it into the machine. P, we have P. We plug it in. And the machine lets us know what Q is going to be. It pumps it out. So that's basically what this equation, or that's basically how to solve these type of questions. When they give you the law of demand, they're just basically saying, let me read the question. It's he has noticed that demand increases as the price decreases. He came up with a formula. It's all kind of redundant information. You kind of just need to know the formula, the machine you're going to use. And at that point, you just read the question to kind of dissect what you're going to be putting into the machine. Find the quantity. Well, we need to find the quantity, so we're not going to be putting it into the machine. But we were given a price. We're given a price of $3.75. So we can put that in the machine. And we need to find quantity, so we use the machine. We plug in the values that we know, and it pumps out a value for what we don't know. I hope that makes a little more sense. B is basically kind of similar. It's basically saying how instead of, he came up with a law of supply for the watermelons. And the law of supply is P is equal to S of Q. What is that? S of Q. S of Q, remember how D of Q was demanded quantity? S of Q is basically supplied quantity. Quant. S of Q. Quant, quantity, shorthand. That's a Q, that's not an A. I don't want you to think that, it's Q. So P is equal to S of Q, which is equal to 0.75 Q. So P, just how in the previous one, if I can go back, let's see if we can go back. No, that's it. Okay. Let's go back. There we go. Just how P was equals to D of Q, so that means that D of Q is equal to the equation. P is equal to the same equation, same name, same concept, different names. It's the same thing with this one. Same concept, just different names. This P is equal to 0.75 Q. S of Q is equal to 0.75 Q. They mean the same thing. And I keep hammering that for a reason. But basically remember, P is equal to S of Q, just how Y is equal to F of X. So this is the equation that they give you. You don't really need to worry about how this equation came to be. You just need to worry that this is the equation you're going to need to work with. So the book is basically asking you, let me pull out the information right here. Find the quantity supplied at the price of $5.25 per melon and at $3 per melon. Well, think about the problem we did beforehand, this problem, where we used the machine to help us find information we don't have. This is the new machine that we're working with now. This right here is the new machine. This isn't very podcasty because this is like example. So I'm going to try and make this podcasty. P equals 0.75 Q is the new machine that we're working with. So what do? Same thing as always. We write down what we know and what we don't know. Find the quantity. Okay, so we don't know Q. Q is something we need to figure out. But we know the price. The price is given to us. Price of $5.25 per melon. So that's the price, $5.25 per melon. We use the same thing as we did before. We use this information and we plug into the machine the info we have. And so I actually did the math right here. $5.25 is equal to 0.75 Q. P, we have P. They gave it to us. So we plug it in. We plug it into the machine. And this machine, we do the math, and the machine tells us that Q, the value of Q is equal to 7 or 7,000 because we're working in the thousands. Same thing with 3. They gave us a price of $3, but they want the quantity. So we use the machine. The machine P equals 0.75 Q. And we plug in the values we know. We know $3 price. We plug it in. The machine tells us, does the math, and it tells us Q is equal to 4 or 4,000 because we're working in the thousands. So that's basically how you solve these two questions. Is basically you have the machine you're working with. They give you the machine you're working with. In the first case, in example A, it was P equals 9 minus 0.75 Q. In example B, it was P equals 0.75 Q. But they mean the same thing. It's just the machine that's being used. In the first problem, we used the machine. P equals 9 minus 0.75 Q. We plugged in the price. because that's what we know. To find Q, you know, pump down the value for Q. Same thing. We, in the example B, we used a different machine. We used the machine P equals 0.75 Q. They told us a price and wanted us to find a quantity. So we use the machine. We plug in our price, 5.25. The machine does the work, and out pops out the value, Q equals 7. Alrighty. So let's move on to the next one, C. Graph the solutions. So graphing the solutions, I mean, I don't really know if you want me to go over that. It's kind of self-explanatory. You have, you know, once you have like for example, this one right here, like, you know, we plug in price, which is 5.25, we get 7. That becomes, you know, our coordinate points, you know, 5.25 over 7. You know, that's P, that's Q. You know, so that's basically saying, you know, like these, the P that you plugged in and the Q you get, that becomes your